This video should show you what to do in terms of creating the velocity, acceleration, and position graphs with the three different starting ways that you're going to need to do. So first we'll look at starting with a position time graph, then we'll look at starting with a motion diagram, then we'll look at starting with a narrative. So when we start with a position time graph, just remember that anytime that you go from position to velocity, the slope of this line at any given point is going to tell you the value of this line at any given point. And then the slope of the velocity will tell you the value of the acceleration. So we're going to go down this way. So if I look here, I see that my slope is staying the same the whole time. So I know that my velocity is going to need to stay the same the whole time. And it has a negative slope, so I know my velocity is going to have to stay the same at a negative value. So it's going to be just a horizontal line on the negative side. And then this slope is 0 and staying the same the whole time. So my acceleration is going to be 0 and staying the same the whole time. If I look at this one, my slope is changing, so I know my value is going to need to change. So I'm not going to have a horizontal line, I'm going to have a diagonal line. And if we look at this, I start with even though I'm on the negative side of the position, the only thing that matters is the slope of the line at the beginning. So if I put my pencil on that line, or my pen, I can see that that is a positive slope in terms of where the graph is. So I'm going to start with a positive velocity, and if I put my pen at the end, that is 0 slope because it's a horizontal line, so I know I'm ending at 0. So I'll just connect those two dots, and that's my velocity graph. Now the slope of this one tells me the value here. So this is a constant slope, so it's going to be a constant value, just like always, for your acceleration. And since it's a negative slope, it's going to be a negative value, so it'll look like that. In terms of the motion diagrams, we're going to look at these and look at the motion diagrams to give us a couple pieces of information. What this will give us is my initial position, my final position, my initial velocity, and my final velocity. So I'm going to go through and just put some dots on the graphs in this case. So I can see I start on the negative side because this is 0 right here, negative side, positive side. So I start on the negative side, so I'm going to start down here, and I end on the positive side, so I know I need to end up here. Now, whether it's going to be a straight line, curve up and out, or out and up, is the question we'll get to in a minute. So the velocity, I can tell this is a very small value right here because the dots are close together. So I can either call this a small positive value, or this is also how motion diagrams show something stopping or starting from rest. So I'm just going to call it 0 right there. But if you called it small positive value, that's fine as well. And then here I have a big positive value. It's positive because it's going towards the positive side for both of these. And this one's bigger because the distance between them is bigger. So I know it's going up there. Your velocity graph will always be just a diagonal line. So connect the dots, right? Or it could be a horizontal line. I'm just going to go back to the acceleration because this is what we just did for the position time graphs when it was given to us on the last paper, is that this slope tells me this value. So this is a constant slope and it's positive, so I'm going to have a constant positive value. Now if I want to find the position, I'm not even going to worry about the acceleration. That's gone. Don't even pretend like it's not even there. The only thing that matters is the velocities. Okay, well, if slopes of these graphs tell you the values here, the values here tell you the slopes here. So if we look at this value, it's 0. And by value, I just mean, is it above the origin, is it at the origin, or is it below the origin? So this one's right at the origin, so that's 0. So I need to start with 0 slope. Well, 0 slope looks like a horizontal line, so it's going to come out a little that way. This is a positive value because it's above the origin, so it's going to need to end with a positive slope. Okay, so if I put my pen down, that's 0 slope, that's where it started. Positive slope, that's where it ends. Now, to connect those, I obviously can't go diagonal, I can't go this way, I have to go in this direction, and it'll curve that way. So if we look at this one, again, it gives me those initial and final values for position and velocity. So this time I start at the origin, so I'm going to start right at 0, and I end on the negative side, so I know I need to get there. Okay, so again, don't worry about which way it's going yet. The velocity graph will tell you once you figure that out. So my initial velocity is negative because I have a big distance between the dots and it's going towards the negative side. So I'm going to put a negative dot there. And it's either a very small negative, because those are my last two, or again, that's how it shows stopping or starting at rest, so it looks like that. This value right here, your velocity graph, just connect the dots because that's always going to be a constant value. It's not going to change, a constant slope. It will either be diagonal or horizontal. So this slope is positive. That tells us that this value down here is positive. So that's positive. And again, when I'm looking at my position, I'm going to pretend like this isn't even here. And I'm going to go up to this graph. The values here tell me my slopes here. So this is a negative value. So my line needs to start like that. So it's going to start downward. And then this is 0 value, so it needs to end like that. So it's going to end this way. So it's going to curve down and end like that. When you look at the questions that are the narrative, the ones that just give you written out information, I didn't write out a paragraph, but this is what it tells you. It tells you what your initial position is, positive, negative, or 0. Same with your initial velocity, and just the acceleration overall, because remember, our acceleration is always constant. So when I see my accelerations written out, I can just straight ahead go ahead and draw a horizontal line at whatever that is. So that's at 0, so I draw it right there. And then I can look at where I'm starting. So my initial velocity is positive, my initial position is positive. So go ahead and put those dots on right away so you make sure you start in the right spot. And this time, instead of going this way, we're gonna have to go this way. So before, the slope here gave me the value here, slope here gave me the value here. But now I'm going the other way, so the value here gives me the slope, the value gives me the slope. So this has 0 value, so my slope has to be 0. So that means horizontal line. This value is positive the whole time and it never changes, so my slope needs to be positive and not change. So that's going to be a diagonal line like that. Okay, if I look here, my acceleration is positive, so I'm going to go ahead and just put that in. My initial velocity is negative, and my initial position is negative. Okay, so look at this as you go through it. This is a positive value, so I need to have a positive slope. So I can do this. Now, where you stop this line, there's nowhere to tell you what it is. You can stop it at the line, you can go through. I'm going to draw it first, stopped at the line, and then I'll continue later and show the other option. But in this case, see how I started with a negative value and ended with 0 value? That means I need to start with a negative slope and end with a 0 slope. So I'd come out this way and curve to flat. So those match. Negative value, negative slope, 0 value, 0 slope. Now, if you drew this and you kept going with the line, now your final value isn't 0, it's positive, meaning it needs to end with a slope that looks like that. So you're just going to continue this line and it'll come back. It could stop there, it could go all the way through, it doesn't matter, as long as this final slope is positive to match this final value.